Hello, everyone. Welcome to another Wolfram language design review. This topic that's on first has been a very evergreen topic, which I'm not sure we really should be talking about here, but let's
Despite the fact that you sent an email demanding that we discuss this here.
oh, at some generalized level.
Uh, right. So, I mean, these are basically things that, the first two categories we don't really need to discuss. They're just obsolete things. So there's seven symbols in this category. And those that are used by one or two functions, geodisk and geodistance, which I believe are used by Wikipedia data. Head,
We
which
should provide an alternative syntax for that, because I think that the don't we have some other sorting option?
right. So I would say, so there's a couple of things to say here. So for the values functions, I'm not entirely sure we even still need the option. It's never been documented.
Okay,
Um, it, it's there to restore the I don't know, V4 behavior of just sort of sorting out the raw rule table instead of
okay,
sorting it,
yeah,
uh, sorting and right. It's basically whether to sort the constant values, the hashable patterns.
right.
Um, I mean, do you ever not want it sorted? I mean, I
Yeah,
suppose if you have a
no,
really
no.
long one, that's maybe if you don't care about the time, but so maybe we
I
can just
can't.
remove this.
I think we can remove that. I mean, by the time it's an option that hasn't really been used since before a lot of our users were born, it's I think
Right,
we can.
right. Then it's used, but although I don't think it's documented by solve always, which is, this older solve function that we don't really use very often anymore.
I mean, at
Um,
one point, solve had such an option, but it was removed, right?
Right. It's now a system option, and it's called reorder variables, which is actually or what it has here is allow reordering. It's actually the actual functionality of the option. It allows a reordering of variables.
Okay, so wait a minute. You're saying that solve now has that as an option.
no,
No,
it's a
no,
system option.
it's a system option that affects solve, so it has been hidden.
Oh, I see.
Right. And so the only place where it's sorted is documented is Grosvenor basis, but it's not really sorting. You know,
Yeah,
it's
it's a totally wrong name for the option there.
right.
So, I mean, that's bonkers. What
Right.
is the correct name for it?
Allow reordering.
Allow reordering, yes.
So, wait a minute. Is allow reordering a thing that is
No.
Right. We could call it allow reordering, allow variable reordering if we want to be a bit more specific.
well, can we explore whether that's what we could use for these things? I mean, is that, and what about logical expand? Is also an eliminate seems to also have this.
So eliminate, it's the same meaning as in Grosvenor basis. I don't know about logical expand.
Can you look it up? I mean, can you look at it?
I can look it up or ask Danny
So it's
what
either
exactly it's doing.
allow, sorry?
I can look it up or ask Danny what this option is doing. So yeah, I'm not quite sure
Okay.
what it's
So
doing.
of these, what is documented?
I could
Anything?
imagine for the
So
logical expand because there is a mathematical meaning to what a Boolean formula means, and there is a programmatic shortcut meaning to what it means. Like if you have an and it returns, like say you have
Yeah,
a million and clauses,
I
you know,
understand. Some of them don't evaluate and they can shorten themselves by just
right.
knowing that one piece doesn't evaluate.
Yeah, same for, yeah. So, which is it's a control flow use of Boolean, which is not mathematical, but
I
it's
understand. So allow
programmatic.
variable reordering might be relevant there.
Yeah.
Okay,
Yes.
so
the only place where it's actually
It's not,
documented today is Grosvenor basis, to answer your question.
okay. So I think we should try and turn that into allow variable reordering and dedocument it. And these
Okay.
other ones where it exists, if it's useful, have it be allow variable reordering, and that's what it should be. What is
Yeah.
main solve? Main solve isn't a documented function, is it?
No.
No.
So I mean, again, can we mark these by? Okay, so those are those that more or less deals with all of these, I
Yep.
think. Okay, Packlet site register. How could a modern function have ended up with something like that? That's crazy.
Maybe someone that doesn't know design.
Because you weren't paying attention when Todd showed this to you.
He should.
I mean, right, this is what it always used, when it was still in the Packlet Manager
But it
context.
isn't even documented here.
Oh, okay. I did not notice that. I wonder if it's documented in a tutorial or if it's just
Okay,
not.
well, so let's find out what the story is with it.
Okay.
What does it do?
It puts it at the beginning rather than at the end of the list, right? It's
When it in terms of the list of Packlet, I mean, it's a
sites.
priority order
Yes.
for. And what about things that affect $path and other such things? What's their, beginning end, beginningness, endingness, so to speak?
They generally
They put at the beginning, don't they?
right, they generally put it at the beginning.
And what does Packlet site register do?
It generally puts things at the end, I think.
Okay.
Uh,
How about we find out about that and then let's discuss this again and see whether we can unify the beginning or end thing, and maybe there's an option for beginning or end.
okay.
Makes sense for all of these functions.
I don't think they particularly make sense in the context case, because in the context case, right, when you load the package, you want its symbols to take priority over previous guys, right?
Yeah,
So,
probably. I mean, unless you don't, but
right, and that's why we have context aliasing, right? So
yes,
that we have the rule. Yeah, so maybe what we want here is a rule syntax like we do in needs.
yes, that would make sense. I mean, again, let's just solve this one. It's not documented. I don't think we have to hyperventilate about it. If it's useful, then figure out a way to provide that functionality. If it's not useful, just don't document.
Okay.
Add to class path in JLink has the same prepend option.
Well, that's how it got inherited here, I'm sure.
That's a good
And
guess.
they were both of these functions were written by Todd, so it's hardly surprising.
Yep. And then the prepend option for add to class path was made for alpha and is very useful, at least in that context.
Okay, this business here. This should be done differently. This should be done with an association.
Yeah, I mean, in a weird way, it's like they're not even options. It's saying,
Right.
oh, you can't use them at the same time, but that's
and
not how
sub
options
options and so on. They should be just keys in an association.
Mm-hmm.
It's a minor thing, but we should probably fix that. And that we get them off this list.
Okay.
Current notebook image.
Right. So these are experimental functions. They don't even document this option, so I can't even tell you what it is because I don't think anybody is. I don't even know who here, who's left who had anything to do with current notebook image.
Well, okay, there it is. Lovely.
Yeah.
It's cool. It's surely useful, at least for QA. I should be using this more, actually. This is really nice. And I should use this. My gosh. I don't think this option is anything useful. So, I mean, I would recommend just removing it. I mean, it may be some kind of thing with, I just don't see what it is. Let's not worry about it. It's probably a thing to wrap an additional head around things.
That doesn't make any sense.
Yeah, okay.
I think it's probably, I mean, to the extent it may or may not do anything, it's probably, you know, like some sort of header or something,
Yeah.
right?
Well, I don't know what it is, but let's find out what it is and bring that back here. Okay. Create document. Doesn't that have?
So in this case, if memory serves me correctly, I'm not sure it does, but if memory serves me correctly, create document had notebook file name as an option before notebook file name became a function.
I see. Well, what's the name in the option inspector? What's the name? Or if I want to find the name of this notebook, how do I do that?
That's notebook file name bracket.
Yeah. I
Okay,
mean,
so
if you're wanting to find, I mean, there are a couple of different things you can mean by name, but if by name you mean the, you know, the file in which it will be saved, then that's notebook file name. Yeah.
Right. There's also there's also current value of window title that will give you the thing that appears.
Okay, so window title is the option
No, it's not.
because that's just the title.
Window title by default tracks the file name.
No, I understand.
But it can't. But it can be completely independent.
Right. So, is there a thing in the option inspector? Is there something which is the notebook file name?
No.
Because that's a kernel type thing and it's orthogonal to that. Is that correct?
Well, it is
because it lives outside of the notebook, right?
Yeah, it is a front end property, but it's not an option.
I see.
Excuse me.
Right, because obviously you can have identical notebook expressions that are saved in different files, right?
I mean, we don't want to set it, or we don't want to have it be an option because then, you know, it lives in this weird state of, you know, where people can foot gun all over the place.
Okay, all right. Okay, I get it. I've got a suggestion. Maybe the second argument here, which could be a notebook object which it replaces, could also be a file name.
And
so that then it creates something which is unsaved, but which were you to save it would then write into that file location.
So what is OBG? Replaces the notebook represented by
notebook object.
right?
Okay,
all right.
So I think it will be consistent.
So that could be a string or file of if we want to be very pedantic, we could require it to be file of string.
Yes.
Yeah, I mean, right now OBJ I think it can only be something with head notebook object, I believe. So
I would assume that.
Yeah.
That would be my suggestion.
Okay, well, we can. There are a few details that we need to figure out, but I think we can figure those out on our own. That's given that general direction. I think we can work with that.
Okay, button.
Right. So this is the thing that, right, these are all burned into the notebook. So we need to certainly support this forever.
Yeah, right.
It tells you the tooltip expression that's embedded into the box.
It needs another name.
And supporting it forever isn't the problem. We have an aliasing system for doing this, so that's not an issue.
What should it be called? I mean, so tooltip as a wrapper
takes the object to tooltip and the tooltip.
Yeah, I mean, effectively, the option is taking the second argument of the function.
I guess if you had an operator form of tooltip, then it would it would make sense, right?
And perhaps we should have an operator form of tooltip. Why not? It's kind of nice. Except that seems to be something too.
I mean, the viz functions sort of do that, or I mean, where they.
Oh, I see. Tooltip of expert is equivalent to tooltip
Oh,
of
I
expert,
forgot
comma,
about
expert.
that.
Yeah.
I did too.
I'm not sure if it's used much outside of like list plots and stuff.
Okay, so this needs another name.
Tooltip
Again.
value.
Yeah, except it's not really.
Well, technically it's tooltip.
Yeah, I know. That's what I thought of too.
Tooltip label.
Content. I think tooltip label suggests it's yet another thing. Tooltip content. Is that obvious that means the thing that is displayed by the tooltip?
The one thing to know is that if this is none, then there is no tooltip at all.
I see. What do you suggest?
I don't think tooltip content is terrible. I mean, right? If there's no content, then
Well,
we just don't-
and if we have a something like tooltip content, it will have its own ref page, and I can even if it's a little strange, I can document the none value on the ref page. That
Yeah.
it will be prominent.
Mm-hmm.
It's not great because some of it, the default value here, come on, somebody an idea here.
I mean, you could do something like with tooltip, or
Yeah, I know, but I thought about that. But or allow or include tooltip.
What was your objection to tooltip label?
That it seems like it's an additional label. I mean, a tooltip isn't a label. We've got another thing called labeled.
This is specifying the second argument of tooltip,
Effectively, yes.
which the usage message for tooltip calls that argument the label.
right. But we also have things like, well,
Labeled.
maybe not in these particular boxes, but we also have things like plot
Hints.
label and frame label and
also we have
axis
hints
label.
and things. Tooltip display.
Yeah, actually, another vote against label is that default label style doesn't touch the tooltip.
I like that less than tooltip content.
But the default is none, so that just well.
Yeah.
I don't know. That's stupid hacky names like included tooltip.
The contents versus contents opinions there.
Yeah.
Yeah, probably contents.
But I mean, that suggests there is a tooltip, which is
Yeah.
These are things that are generally pressed, but they also have a tooltip. Like hyperlink and so on.
Many of them, yes.
So these are a sort of extra tooltip that is not the primary action. It's something on hover, as all tooltips are.
Yes. There are it's not exclusively buttons, so
Right, like tag, like if you do like binomial of AB / traditional form, right? You'll get the binomial tooltip from the template box there.
Yes.
And there's clearly no button in sight.
Well, okay, here's a hacky idea. Tool tipping.
I prefer tooltip contents.
Yeah.
Tool tipped? No.
Tool tipped wants to be Boolean.
Yeah, I
Right.
know. Well, okay, I weakly like this, but I think this is one of these. It isn't that broken right now. Let's
Let's brainstorm some more and come back with something better.
Yes.
Okay, that's fine.
All right, we finally made it through these.
Yeah.
Could we come back to logical expand? Now I checked what it's doing. It is actually sorting things. So maybe it should have the option sorted or something like that.
What do you mean it's actually sorting things? What does that mean? I mean, it's sorting
If you do logical expand of B and A, it will return A and B, and it will actually sort it with sort.
Oh, I see. Well, that's just a reorder variables, isn't it? I mean,
No,
well,
reorder
it's reordering variables. You reorder them for algorithmic advantage. Here you actually sort things.
oh, but it's the same thing, isn't it? I mean, these are
No.
all commutative express. Look, these are commutative. I mean, A and B would be.
With
Look,
side effects, it's not commutative.
Of course not. I understand. But this is allow, well, we were talking about allow variable reordering, right?
But it's not, it's sorting. If
Why
the
is
top
that?
level is and, it sorts clauses.
Yeah,
If
it wouldn't
the
be
top level
allow
is-
variable
Right,
reordering. It
I
would be
mean,
force variable
It's
reordering.
not variables.
Right.
I
Yeah.
see.
that
We
too.
call
Yep.
clauses.
Right. It'll, yeah. I mean, well, does logical expand, give us everything in terms of flat things? Then it might be the same. But yes, it's doing sort on the.
It's the actual sort, so it alphabetically orders them, not for any particular mathematical reason. It just sorts them.
This is a very, very old function.
Yes. And it's undocumented.
Undocumented.
Yeah.
Who
So maybe we
cares?
just don't worry about it.
Yeah, let's not worry about it. It's been undocumented for nearly 40 years.
Yeah.
I think it's a don't worry about
I
it.
presume the default is false.
Sort is true.
Oh, it's true. Interesting. Which is why the not Q and not R. Well, I guess that we would have to try different variables, but I wonder
Yes.
if the not Q and not R are coming later because they're not symbols.
I think it isn't broken. Let's not fix it. We don't have to worry about it.
Okay.
Okay, let's move on. Okay, fine. Okay.
So the names are horrible. I mean,
Which names are horrible?
BasicSimplify and BasicSolve. That's just meaningless and horrible. But also, as they have currently been implemented, giving them sort of the same name makes them, sound more similar than they really are. And so so that's another thing we can get
Maybe
into.
we should describe them first before.
Yeah, right. Well, I was going to before somebody started.
Okay. But can we describe them now?
Okay.
Yes.
Okay.
Right. So BasicSolve, as it's currently implemented, looks for real quote unquote simple solutions. BasicSimplify is simplify using a set of assumptions on variable names and that all variables are real valued.
What's the definition of, in quotes, simple?
Well, whatever Stephen and Adam are.
Well, there is no definition of simple solution. It's actually not. So right now it's trying to produce solutions without any conditions on them. Meaning, if there is an infinite set of solutions, we give a finite subset of it.
Okay. All right. So look, I think.
All right. Now
Yeah.
I mean, one of the issues I want to point out is that, by focusing exclusively on real solutions, that means we can't solve x squared plus 1.
I understand it, which is probably wrong, and I'm not sure that this is the right thing to do. I mean, that's
Yes,
something
isn't
I
that's the
didn't
point here.
specify that.
All right.
You know, somebody else introduced that idea.
Yes, so I should say that I've also said that I think the function is different from that design issue of whether have only reals or not. I think that's a bit too stringent, and our aim is to be useful.
Right. Let me say something. We
So-
need we need some good specification for the function. We cannot have specification by example. Like we want to get complex solution in a quadratic equations, but not in other equations. We either can have them or not. It's a function that, you know, complicated recursive algorithm. We cannot define it by a few examples of simple.
Okay, so let's talk about what we want. I mean, for example, if the only solutions are complex solutions, we probably want to give them. If there are 5 solutions, of which 2 are complex, we might want to give the 3 that aren't.
If we have a complicated equations that doesn't have real solutions, and finding complex solutions will take a long time, do we work hard on trying to find complex solutions?
Sorry, I'm sorry, what? If it has no real solutions?
We have, yeah, so we have a
Yes.
complicated equation that doesn't have real solutions. Do we go and look for complex solutions,
I would think
however
so,
long it
yes,
takes?
I would think so. Look, basic doesn't mean fast necessarily. It means, okay, the main issue is if I say basic solve of x to the n equals a for n. Okay.
That's a nice solution. I'll try solve on it. Well, that's okay, but this one is, I think, not so bad.
Right, but there are plenty that are really ridiculous.
Yes, and they're in the first few examples in the documentation.
Well,
I try e raised to x equal to 1.
Well, maybe this is a better example. Sine of x equals 0 for x between the two. Whereas
It's kind of weird.
It's solutions between -10 and 10. That's how it's defined.
Okay, but I think you're look, you're kind of, we got to be a little bit more intelligent here about how, you know, I think the answer to this should be x equals 0 to this thing. So you say it can't work by examples, but here's what we got to do. We know examples that have got to work. We have those data points. Then we fill in between those with kind of definitions. Okay,
That's not really how it works. So see,
I don't care.
imagine
Yeah.
you have arbitrary transcendental equation,
Yes.
right? We can find solution in some bounded interval.
Yes.
It's not there is nothing. Yeah. So
How
this
does
particular
that happen with 3 of them?
it's the order 3 solution.
Okay, I don't think we should do that for basic
multiplicity.
solve. I do not think we should do that for basic solve.
Oh,
Don't do multiplicity.
Okay, yeah, we can remove the multiplicity. Yeah, sure. So anyway,
we can use all the people have seen cases here, right? So one source of problems is assumptions, you know, for parameters.
Mhm.
Them being complex valued almost blocks everything and generates very complicated situations.
Yep.
And most people, like high 90s%, are not interested in complex parameters.
Yep.
There are some, but it's not.
Right. And these are mostly not the cases where we are most outrageous are not complicated polynomial equations. They're equations that are, you know, things like this, for example.
Yeah, log equations. But those also get particularly nasty over the complexes. That's where they kind of
I
really
understand, but we can't do that in that case. I mean, that's
right.
And
so
apps and other things.
But we
which
already introduce a somewhat strange rule. So if you try to solve it over the reals and you find solutions, then you're fine. You give the simple solution. If you cannot find solutions over the reals, then you go and do the thing over complexes and get the complicated solution, or what?
I think it's, yes, let's just think about it, okay? Let's just think for a second, all right? Somebody is trying to solve an equation. We say, the equation has no, you know, we can't solve the equation. That's a silly thing for us to say.
Well, we say just that there are no real solutions. There are equations that have no solutions.
I don't care. The fact that look.
Actually, it's very good to be able to say that there are none.
Over the real. Okay,
look,
we try and give a real solution. If there isn't a real solution, we give a complex solution. That is good behavior that's useful to people. Okay.
Right. Although, again,
we're trying to deal with the following problem. I am fed up with having practical equations that show up in things I'm doing and us having the stupid pedantic nonsense where we're saying, oh, but if it was a complex this and that and that, then this might happen. I don't care. These are equations
right. Well, yeah. Well, I disagree with you that sine of x equals 0 is in that category, right? Because I think any high school student who's passing their trigonometry class knows that that's n pi. Now, how we want to return that solution is something we can.
Fair enough. But I mean the case that
and so again with multiplicities, I mean again that's something that you talk about a lot in high school algebra classes. So maybe you do want the multiplicity. Right. So that
should basic solve exactly. Should we get complex solutions here in sine x equals 2?
I think probably yes. Yes, but not this one, not this mess.
Okay, so just complex solution
The
cut down
first
to
the first one. How do I get the first
whatever
one?
is the first one or first two?
How do I get the first one out of this?
C1 equals 0.
How do I do that?
Replace C1 with 0.
What do you mean? Well, yeah. It's C of 1 of 0, goes to 0. You could type this in.
You got first two. I don't know which one is the first one. Well, here the arc sine 2 I guess looks better.
Yeah, I mean, that's another thing. Is there heuristics about simplification here? That if there are two solutions and one of them is,
Should we give just one, or if we have two, why not give two?
Probably we can give two. Yeah. I mean, this is going to be a heuristic function. No question.
Maybe that's what it should be called.
Yes.
Heuristic solve.
Nobody understands that. That's exactly going after the market that this is not for.
Yeah. Simple was there early on.
I think basic is a pretty good name.
Yes, I think so.
Simplify doesn't work. So we just have to make sure that this, okay. What this is doing is it's kind of a, damn the torpedoes, get me a basic result because I don't want any pedantry. Yes. And it is our job to make the thing work as well as we can, knowing what the pedantic solutions are, and to navigate that and give the best results we can. And is it easy to do? No, it takes judgment to do that. Are we going to have something that's mathematically perfect? No, it's going to have weird corner cases because that's the nature of these things.
I think that we should I think we should show the really positive things. I really completely with you, Stephen, and I hate what we do with log and exponentials and those power, all of those things. That's ridiculous.
Yeah. So let's know the data points where we know what we want to get. And then everything else, even if for polynomials, we did pretty much what solve does. That wouldn't be terrible. It's just these things where the thing gets itself tangled up with complicated Riemann surfaces of logs and things like this. That's where we're losing.
Okay, so polynomials just return all the complex solutions as they are.
I think that will,
I think it'd be fine.
That is, I mean, I think that is what one would expect, with somebody taking algebra 2 and they learn.
That's
also fine. Standard assumption, I think, is that the parameters are not complex.
The A, B's, and C's are real. Yes.
Yeah.
Right. The symbol's not in the variable list.
Right. Fine. So those seem like reasonable things to do. Polynomials, we get the full treatment, assuming that the parameters are real.
Right.
Right.
Yeah.
Or
what happens if there's
not assuming this if it's more convenient, like assuming that parameters are real actually makes it more complicated.
You're right.
Yeah.
You're right, Adam. Okay, can sometimes be bad.
Right. So I think we've got a clear direction
But
there.
for those logs and stuff, it's the number one excuse I've heard forever. It's like, it's complex. I don't know what to do.
Yeah. So cut
I mean,
that out.
complex in the sense of complexes.
Yeah.
Right. Yeah. If the right.
Right. So I think
And
we've got a plan, a partial plan there. So let's talk about the more difficult case of simplify. Okay, where you're using heuristics for variable names, right?
Yes.
Which you're not showing here.
there,
You can try opening the documentation page, ref
Okay,
page for it.
But I just want to say also for solve, should we have heuristics for variable names in solve as well for some integer equations?
Let's start it here, don't you think?
With simplify?
Yeah.
Yes.
Yeah, that would also make solve really complicated. Like if things automatically become integers and solving over integers, it's really complicated.
You're in Diophantine territory, and that
Of
might
course,
be really
I
hard.
understand that, but I'm saying when it can be solved, look, if we've got a 2n equals 3,
Uh-huh.
I mean,
But you enter incompatibility territory now. Incompatible changes.
with what?
With all of a sudden assuming new things.
Well, we're going to assume them for simplify.
well, yeah, not an actual simplify in this new.
No, in basic simplify.
In
So
basic
I'm saying
solve.
in basic solve, the question
Yes.
is, if basic solve, I mean, I don't know. If basic solve, if we did basic solve of m squared plus n squared equals 25. Okay. So I want to solve for m and n. See, this is a case. So in the, when there's a Diophantine condition also, then obviously we don't need, right? So in that case, that's not a very useful solution for somebody who's expecting the Diophantine result.
All right.
I mean, if it can be done, I'm all for it. We just thought about it.
So what happens if either it cannot be done? Should we revert to trying real or complex solutions? And second, what happens if it can be done but takes forever and maybe people weren't expecting that those things become integers suddenly?
I'm not sure. I mean, in the case where it's going to give an error message like this, you might as well try and do it, right? Because an error message doesn't help anybody.
Well, this particular error message just tells you that one of the variables became parameter.
You know what? If you typed this in, right, with m and n, asking to solve for m and n, what do you want? You want a solution for m and n. You want the Diophantine solution. If you typed m, then you get the thing, or typed n only, then you get the thing below.
Yeah.
Right? So in other words, if the thing you asked for can only be achieved for you by going, integer, then I think that's what you should do.
Right, but if you type something like x to n equals something, then
hold
we
on,
can
hold on. You're look, I got to tell you. Okay, that's a nice result. That's what I would like to get in the other case.
Yes. So one thing is that in the first case, you got an overdetermined system, underdetermined system for m and n.
Yes.
So I think that would be one way to recognize that you need to do something clever.
Right.
So then you won't get deterministic somehow or the other, and then you have some.
So the problematic case is if your variables, some of them have the automatic integer assumptions, other not, and you get a complicated mixed real integer or complex integer system that maybe somebody wasn't expecting.
Yeah.
Okay. Well, let's look at those cases then. I mean, look, Adam, this is not what. This is not the kind of thing you've been doing for the last n decades, so to speak. This is a bunch of heuristics.
Right, and I'm afraid that if the heuristic automatically combine, you'll get really weird, unexpected things.
Okay, this is the life of Wolfram alpha forever and ever and ever, right? And turns out people find it useful. So it has a bunch of heuristics for this. I assume you've looked at those. Have you?
In alpha, no.
Oh, for goodness sake. Well, please do. Okay, please do. That will be the obvious place to start, since we've been debugging that for the last 19 years. Okay, so that's the place to start. There's nothing really even to discuss before you've looked at that. Sort of assumed you'd looked at that.
Just one small
Okay,
comment that in the underdetermined case, I would say even if they said X and Y and it's underdetermined, it may make sense to look for the integer because, I mean, the fact is you might get something more useful, that's all. I mean, so
yes,
it's like
I don't disagree. But what was the case that Adam was raising about exponentials? What was the case you were raising where you said this is a case that's going to be difficult?
Oh, so the case where it's not just the expansion, but basically you get some system where some variables are integers and some variables are real based on their names, and people may not expect that, and it will go into something
Why don't you
really
look at what's been
complicated.
done in Wolfram Alpha? Okay.
Okay.
Why don't you make sure you understand that first? Okay, let's talk about simplify. Right. So.
Well, I mean, one thing that's worth discussing about basic solve, which I'm sort of raising here, is does the presence of an I sort of
promotes it into the complex world?
Yeah.
So yeah. Input.
So our X. So in that last input, I mean, in this case, it doesn't matter because this is something that holds true over C. But so does X suddenly become a complex variable because there's an I in the equation?
I would think so.
Oh my God.
Okay.
Yeah,
look,
I think that's one of the rules that will certainly produce something really weird. Like, so the function is recursive, so it produces I in a recursive call.
Maybe we need a different team to build this. I mean, we built things like this in Wolfram Alpha for years.
Yeah.
Why don't you make sure you understand exactly what's been done?
I will read it, but also one thing that I would like to mention is that Wolfram Alpha solves things that fit on one line, and are solvable in 3 seconds.
Yes.
And so should this be this kind of function that say it's a too large problem, or and we cannot solve it?
No, we will try and do it, but I mean, this is not going to specialize in expressions that are 5 pages long.
What if somebody does type something that's
then we run it. Then we run it, and if necessary, we revert to using ordinary solve.
Yeah, I think that the users would know basically what function to use. Whether they would know whether to use refine or use simplify or full simplify at the moment. So there's an audience that will understand that this is where they need to go, or we make them go there by doing enough publicity around it. But
well, okay. The basic point is
I'm not familiar with the code either, but my guess is that Alpha is just using solve and refine and so on, but then post-processes the results in order to
well, and probably pre-processes results.
Why don't we look at it rather than
probably if it goes to an lower length after 3 seconds, it just gives up.
But that's because of time constraints and so on. So you just leave out the time constraint.
But if you use the same rules and do not give time constraints, then it will just go to nowhere land or produce something completely absurd.
Let's cross that bridge when we come to it. That's not what this is for. This is for, it's like full simplify. If you have something unbelievably complicated and you say full simplify, it's going to take a while. If you say basic solve on something absurdly complicated, it might not do what you expect because it's not intended for that. It's intended for the case where I have a simple, A to the B equals C, and right now it's standing on ceremony and producing a pedantic result that is utterly useless to me. See what I'm saying? It's for cases like that. It's for basic things, hence its name.
Maybe elementary things.
Yeah, but they're not necessarily elementary functions in this.
No, but only for some people elementary means elementary functions.
So we should call it Sherlock solve.
No, I mean, basic solve is a good name. I think elementary solve and elementary would also be good names.
Yeah, they're not. I think it's much better to have less commitment about what it is, and it's just doing the basic things. And if you give it something really complicated, well, then it will do its heuristics, and whatever comes out comes out. But the important thing is that for the cases where anybody knows, anybody who knows even basic math knows, there's a solution for a to the b equals c, and here's what it is. And we say it's something unbelievably complicated with all kinds of conditions and so on. It's like, throw your computer at the wall type thing, because it's really annoying to get that. And there's no easy way to even resolve that, right? That's what we're dealing with here. Does that make sense? I don't expect that.
What does it actually do for a to the b equals c?
What does what do? Solve?
Basic solve.
Well, we just saw it. Did the right thing. Basic solve.
Well, which I think is no different from what solve does.
In that particular case.
Yeah.
There's other cases like this where it does something much more complicated. So
yeah, if you do reduce, you will get something complicated, because that's what it's supposed to do. It's supposed to give the
No, even solve does it. So if you look at the basic solve page, I think it might just if you go for a minute to that page, you'll see that the first few examples are already showing that
if the inverse function stuff doesn't work,
yeah,
and sometimes it doesn't, it often doesn't, then it will do. Then we'll just call reduce and get the complete solution.
John, did you see that little thing?
Yeah, that failed. Did you see that? This is in 15.1 prototype build. Splat. Anybody relevant seeing this?
John, are you seeing this? If you are and you're speaking, we're not hearing you.
Is John still here? Maybe he left.
He is still here. John, are you listening? You're muted.
Yes, I had taken you off my headset. Took me a little bit to restore it.
That's just a bug.
Did you see
it's just a bug in the 15.1 prototype build. Okay, documentation.
So you clicked on the little.
I clicked on the raft.
On the raft, yeah. Okay, so it's working for me using yesterday's build. I don't know
maybe
if it's specific to you or something has broken since yesterday.
Right. So look at just the first 3 or 4 examples. Maybe the second or third example, you see the stuff that's much worse in solve compared to basic solve. I mean, you can try both those.
You mean something like this?
Yeah, exactly. And even the one before, try 2 raised to x equal to 32, and you see, I think, maybe not, but I think that one also. I mean, yeah.
Oh, God.
Yeah, I mean,
this is exactly what we need it for.
So I think this is my problem, that I think, let's say if we had to build a course for high school, we cannot use solve.
Right. So that's why we're having this function. So let's be as smart as we can be, knowing that there will be mathematically unpedantic things that happen.
Yes. So we already have a kind
depends on the high school class, I guess.
Well,
at some point in high school, people expect to know that the complex solution to exponential equation.
I've taught. I mean, sorry, but I've never seen anyone who, yeah, like maybe like 2 people. Maybe like Adam, you might be one exception.
And it doesn't. Those people who are like competing in the math Olympiad and so on don't count.
Exactly. Yeah, exactly. So you don't count, Adam.
So
well, I didn't compete, but we use it for.
I don't count either, so it's okay. You're in good company, Adam.
you need complex numbers for circuits modeling, so we did that in high school for sure.
Yeah,
this is what I mean. We can have a diversity of countries and where we can debate what actually happens in high school math. But
no, but I'm sure that if we could get
I agree we should have. There's no question that we want something like this.
Well, maybe we should call it high school solve.
That's my preference, actually, honestly.
No,
I'm joking.
No. Okay, look, what we've got to
So, right.
sensible things are happening
Let me
here.
finish my sentence, please,
Yeah,
Steve.
okay, please.
Which
Go ahead.
is, didn't we talk about like an instantiate variables function or something that would take that output and, plug in C of 1 goes to 0 and whatnot, which would pop out, right?
Well, find instance is that function.
Really? Okay, so if you're saying if we do find
Because we had the same idea when we did reduce, and our conclusion was find instance. It solved exactly that problem.
Great.
Yeah, you can even say how many instances you want.
Yeah, but look at this.
It's a non-trivial instance.
People?
Yes.
It's a non-trivial one. If you want over the rails, you'll get the
Yes,
the
I
only real
understand.
instance.
Right,
You're,
yes,
you're all telling me the reasons why we want this basic solve function. So
but see, this isn't what I was talking about. I was talking about something that takes %23 and says,
yes, I get it.
See, and we talked about this at some point, and I don't know what
I
happened
don't
with
think
that.
that's the right way to deal with this. Well,
I'm not saying it's necessarily, but it's something. Yeah, I'm not saying this necessarily replaces basic solve.
no, generic instance or something, or some such other.
Yeah.
I mean, we could imagine having a function called basic instance. That might be useful for a
Actually, find
variety of
instance
different
would do
things.
it.
What's that?
Find instance would do it if you take the value rather than the replacement rule in out 23. So do solve values and then do find instance and C1 as the variable. Then it will give you one of
that's
those.
unbelievably complicated. So what I'm asking for, which I think might be interesting, is a basic instance function that will take a thing like this, where there are multiple choices, and give some heuristically simplest case, which in this case would be 5 or whatever it is.
Right. I mean, just something that looks for like, C of K and replaces each of the C of K with something useful.
Right. I like the idea of a function called basic instance, because I think that there might also be cases in other, whenever we're returning these infinite families and so on, I think this will be useful.
So it will be something that would expect the output of solve as the input.
Something like an output of solve, but it could be output of reduce or whatever.
How would it know what is the parameter it should get rid of?
Well, I mean, it could just look for C of Ks, right? I mean, a good starting point would be it just looks for C of Ks because those are the things we use as generated parameters, right?
Right, and also I really like the idea of this function. And I think there are other cases, like cases where we get infinite sums and things like this. Maybe that's not a relevant case. I'm not sure, but I think
actually we built a function for that. What is that? Devendra, for return values from PDE solvers and whatnot. Truncate. What was it called? Truncate something.
Truncate sum. Yes.
What's that? Is that a system function or is that a?
Yeah, it's a system function. And so the workflow. So when you solve differential equations, particularly PDEs, we often return an infinite sum.
An infinite inactive sum because.
Yes.
Or unevaried sum, both are same from this point of view.
Sure, but yes, but we typically return in the case of PDEs, we return an inactive sum.
Yes.
So truncate sum is a little bit like what you're saying. It's like, give me something more finite.
Yes.
Yeah. I agree. This is a very nice idea. I mean, it's almost like basic instance.
But the thing is that this is designed for. I mean, it works for the
approximation,
outputs.
right? This particular thing is an approximation scheme.
Yes.
Whereas this is
so is the other.
Instancing. Well, it's an instancing.
Right. This sort of.
It's an approximation to a set, not an approximation to a number.
Right.
I think we should. Okay, let's look at this. Let's talk a little bit. Okay, so I'm going to suggest a workflow here. You're going to come up with a bunch of weird cases, Adam, where you're going to say, I don't know what the heck to do with this, right? There are 2 steps. Number 1, see what Wolfram Alpha does. Number 2, bring it to a meeting like this, and let's get a big long list of these things, and you can ask me and others, what should we do with this weird case?
Mm-hmm.
Yeah? Okay. And like the decision that for simple univariate polynomials, we just go and solve them, I think is an example. Okay.
Mm-hmm.
Now for simplify, Well, you're not showing.
Yeah, I didn't include, but again, there's a rough page with lots of
Yeah,
examples.
I mean, right, basic simplify
And,
fine.
and it's probably worth just even looking at the notes because there's an explicit list of the variable assumptions in there. Which I'm not sure I totally agree with all of them, but again.
Positive integers, that's interesting.
Yeah,
Right. I mean, is
many
it really
many of the sort of standard and expected transformation actually require positive integers, not just integers.
Or even non-negative integers.
That's really amusing and weird.
Yeah, I'm not sure about that, but
How did that even come up?
Right, because they're infinitesimals. It's epsilon and
infinitesimals. So
Oh, oh boy.
you know, we could make it,
Okay.
rationalize of machine epsilon, right?
Well, does that matter in simplifications?
well, if epsilon squared is less than epsilon.
I see. Well, just less than 1 would be a reasonable thing to say. And less arbitrary than that. I mean, the only issue there is, let's say you have a trigonometric equation. The fact that it's so close to 0 might have an effect.
Right. It's sort of, well, it has to have some specific number there, but it's something that it's supposed to
1
do.
might be a reasonable thing. Again, well, you don't have very many examples yet here.
They're just in subsections.
There is. Let's look at scope.
Yeah, you just need to open up the subsections.
That's
in
useful.
scope.
Yeah, no, I understand.
Oh, sorry.
So that portion just explains that how the rules carry to more complicated variable names.
This is a very useful function.
I think it'll do the right thing in many cases. Yes.
Right. And you know what you're getting. You say basic simplify. It's like.
And I presume if you specify any assumptions yourself, they will override the default one. So if you want alpha to be
no, it doesn't have the assumptions.
There are no assumptions. There
are no assumptions.
You're not allowed. You're not allowed in the.
Yeah. So if you want your own assumptions, just use simplify.
Okay.
Yeah, because I think it's going to get very tangled up if we have ours and yours, and what if they're incompatible, and what if whatever.
Okay. Right. So
this is great.
Yeah.
Very useful. What is the idea here with full simplify list? Okay, that's trying.
That's getting the best and best forms that we saw while doing simplify.
So I think we should have an up to 5 type rule.
Yeah, it's up to 5.
Okay.
No, but shouldn't you allow up to as a syntax?
Yeah, absolutely.
Oh.
Well, it's an auto up to.
It's up to. So it's never exactly, because you cannot guarantee more than anything.
And so are you sorting it by leaf count?
Yeah, or by simplify count. It has the same options as simplify.
Okay. Given that we're having things like this, we should probably have the number recognized function that we already built for Wolfram Alpha.
I think we should build some other complexity functions, Adam, that we actually document. So for instance, so we've done that a little bit, and we've seen external people do that, but maybe this is a good time to actually try to evolve it. So what you would penalize higher transcendental functions over elementary.
Yeah. I mean, this is a typical corpus-based algorithm of the kind that we have implemented for Wolfram Alpha, where obscure mathematical constants have a higher cost than pi, for example.
Right.
Oh, okay. I guess I'll
have to learn about
I'll need to look for in alpha sources for those functions.
Yep. Well, we'll ask people involved.
Itai would. No.
Well, I was, I mean, Jeremy would know better than I would.
Jeremy would not.
I would not.
But we had, for instance, that guy who developed, what's his name, that developed those rule-based integration algorithms? He had a complexity function, which is along the lines that I've written several times.
The author of Ruby.
Ruby, yeah, that guy. What is? You know him, Stephen. What's his name?
Devendra, do you remember his name? I'm blanking on it.
No.
Shit. Super nice
We
guy.
know him. We know him well. Yes.
Yes.
But,
Yeah.
He passed away, unfortunately. Yeah. But,
Yeah.
Yes.
But it's a good idea, and I've certainly implemented it several times, and it's like, I don't want appel F1s, give me trigs.
yes. I agree. That's an important thing. But again, we could just import the number recognition stuff from Wolfram Alpha and have a function that is similar to SimplifyList for, number recognized list, more or less.
Mm-hmm.
And we already have something that's, useful.
Well, depends on your definition of useful, but
I use it.
but before we get into this thing, two things. One is, should we have a one argument form with a default number, and what should that default number be?
5.
Okay. And my second question is, now having had these two discussions, did I bring sort of important points that needed to be discussed, Stephen?
More or less, yes. The only thing
Yep.
is that Adam is still freaking out about the fact that it's not mathematically perfect.
Yes. I cannot control Adam's emotions. I can only control the issues.
Right. But so what I'm saying is,
which is just a way of saying that, have a little faith in me,
Yeah. All right. Okay. But I'm going to say that for Adam and others, bring the weird cases and let's just go through them and make horrifying decisions, because there will be weird cases.
Yep.
I mean, when we were doing this for Wolfram Alpha originally, and all the kinds of issues that come up there are all kinds of things where somebody says, well, what if there's an I in, obviously in the language we have capital I and so on, but in Wolfram Alpha we don't. And it's like, if we say I squared plus X squared, does that mean square root of -1 squared, or does that mean, a variable I? And we had to make all kinds of decisions, which, by the way, were pretty well made, and people very rarely get into trouble. In that particular case, we have the mechanism of having assumptions and so on.
Right. So, yeah. Okay. I'll collect especially
Please.
for those simple cases. I guess so. I guess one of the conclusion is that if you put something complicated in basic solve, then you may get something strange, and
it can go on, and do what.
Yeah, I mean, if you put something that really should be given to solve into basic solve, then we can just default to solve if we have to.
Yeah,
not a problem. I mean, it's intended for basic things, basic results from basic questions.
Right.
It
may be worse than defaulting to solve. We may use the heuristics and get something really strange.
Let's take a look at that. Show us the corner cases, and let's decide what to do for them. Right. I think we should wrap up because I'm late.
We can certainly wait with the zero test until next time, and it might even be better because then Danny will be back from PTO.
Sounds good.
Okay.
I really I just want to say this basic solve, basic simplify. These are really important. They're really worthwhile.
And Stephen, I'm not saying that they're not worth having. I'm saying I still hate the name basic, and there are issues we need to sort through. So, and we've sorted through some of them today.
Yes, this was all useful. Okay. All right. Thanks, guys.
Thank you very much.
See you later.